So let's go through some of these exponent laws. Now these should be review, but you know, it's been a while. Oops. So the product of power laws means if we have the same base being multiplied, what are we going to do with our exponents? Anthony, let's go. We are going to add them. Okay, add them. We add the powers. So these are good to throw on your study sheet, maybe if you don't remember them. Okay, quotient. So if I have same base being divided, what can we do with the powers? Subtract them. So it'd be m minus n. Keep that same base and then subtract the powers. We talked about this one yesterday. If we have a power, so base of the power raised to another power, we multiply them. M times n. It should be a times, or just you can put mn just beside each other, right? Mn. Power of a product. Okay, so if there's more than one thing in our brackets, and we are being raised to the power of m, does this m apply to both of them? Yes. So it'd be a to the m times b to the m. Applies to everything inside the brackets. Even if there's a coefficient there, it applies to everything. We often forget the coefficient, but it applies to everything inside. Same idea for having a quotient raised to an exponent. Would that exponent apply to both of those? Yes. A to the m over b to the m. And the last one, anything raised to the power of 0 equals 1. Yeah. Now, be very careful. If I have negative 2 to the power of 0, notice the negative 2 is in the bracket. That would equal to negative 2 to the power of 0. It would be positive 1. It's applying to this whole, anything raised to the power of 0. So that includes the negative. That would be 1. However, if the negative is on the outside, then the difference here is just the 2 is being raised to the power of 0. And 2 to the power of 0 is 1. And now we'd have a negative in front of that. So notice the difference. Okay? So if the negative is not part of that exponent, then it's going to remain. Cool? Not really. I don't know. Okay, the next two is just review. Do we need to go through negative exponents and fractional exponents? Should we just do a quick review? Okay, quick review. If you have a negative exponent, so let's say at 2 to the power of negative 2, how do we get rid of the negative exponent? Flip it. So where is it going to go? 1 over 1/2 to positive 2. Or 1/4, right? What if we have a fraction to the power of a negative exponent, so negative 2? You flip the y and x, make it positive, and then would that apply to both? Yes. Okay, so negative exponents were flippable. When we have a fractional exponent, so say I have 9 to the power of 3 over 2. Whenever we see a fractional exponent, we can change it to a radical. So that would be square root of 9 all cubed. Yeah, because it's power over root. So it's power on top, roots on the bottom. Square root of 9, it's always easier to make it smaller first and then bigger. So square root 9, 3. No, yeah, 3 cubed is 27. Yeah, you got it. Okay, and that goes both ways. You can change a radical to a fractional exponent or a fractional exponent to a radical. All right, see, that wasn't so bad. Okay, we won't go through all of these. Well, some of these will be really quick. Why don't you try A through F right now? Just A through F. Okay, so reviewing those exponent laws we just talked about, give A through F a try. Okay, What did this become here? We have the same base being multiplied. X to the 7, we add the powers. Same base being divided. What do we do with our powers? Subtract them. 7 minus 3 gives 4. Okay, what would this simplify to? A to the 4 times b to the 4. Yeah. Make it more simple. Okay, next guy would be x squared over y squared. Same base as being multiplied. What are we going to do with our powers? Add them. What's 5 plus negative 2? 3. And 6 to the power 0 is 1. Okay, let's look at the next guy. What would this be? 1, because the negative's on the inside, but this guy would be negative 1. Okay, be careful. Is the 3 is it in part of the power of 0? No. So really it becomes 3 times, what's x to the power of 0? 1, and 3 times 1 is 3. Very good. Okay, let's look at J. This would become, if we have a negative exponent, we want to 1 over 3 squared reciprocal, or 1 over 9. Okay, this is a little weird because this negative is not like wrapped in brackets inside. So you could almost think of it as negative 1 times 4 to the power of negative 2. Okay? So when you flip this one, what would it look like? 1 over, yeah, you could put the negative on the top or the bottom. Okay? Now when you square it, are you squaring negative 4 or just 4? Just the 4, and the negative remains because it's not in brackets. So this would be 1 over negative 16, or negative 1 over 16. Okay, so notice the difference. If the negative's in brackets, yeah, then this would be in brackets, but it's not. Okay, so that negative 2 is just applying to the 4, not the negative. Yeah. This looks like a repeat. No? Yeah, okay. Okay, what about this guy? 4 cubed, yeah, it's reciprocal to make it a positive. We move it to the top. And 4 cubed is 64. Okay, this guy I love. Are there any exponent laws for addition? No. So, if we have addition, we actually have to evaluate them individually and then add. So, no exponent laws for addition. So, 3 to the power of negative 2 would become 1 over 3 squared plus 1 over 3, or 1 over 9 plus 1 over 3. So I'm just actually going to square that. In order to add fractions, what do you need? Same denominator. So we have 1/9 plus, how do we make this guy a 9? Times by 3, so 3 over 9. So that will add to 4 over 9. Keep the same denominator, add the numerators. Okay, so be careful of addition. No exponent laws for addition or subtraction. Yeah, only multiplication and division, and then exponent to exponent. Okay, so what's happening if we have two brackets beside each other? Multiplied. Okay, so you can almost think of it as SNL, sign, number, letter, not the show. So the sign, like if you have a positive times a positive, it's a positive. And then our numbers, 2 times 3, 6. And now our letters. So a times a cubed, same base being multiplied, what do we do with our powers? Add them. What's the power if you don't see it? These are ones. Yeah, you might want to write them in. So 1 and 3 makes a to the 4. B to the 4 and b to the 1 becomes b to the 5th. And c to the 1. This is only 1c. Okay. Does that look familiar? Yeah, a little bit, hopefully. Okay, I like this one. A little different. That negative exponent, who is it applying to? Just the x. The negative exponent is just being applied to the x. There's no brackets. So who's going to move to the bottom? Not everything. The negative 7 stays on the numerator. It doesn't have a negative exponent. Only the x moves down to become a positive exponent. Negative numbers are okay, just not negative exponents. And there you go. Now we're done. So here, the negative exponent just applied to the x, because the only way it would apply to both is if there was brackets like that. Then they would both go down. But this one, there isn't. Okay, some division. So sign, number, letter. Sign and number go together. 16 divided by negative 4 would be negative 4. 8 to the 6 divided by 8 to the 6. Yeah, 8 to the 0, they subtract, and anything to the power 0 is 1. So they reduce out, right? Because they're the same. B to the negative 3 and b to the 3. So when we subtract, be very careful of this. Negative 6, because we have minus 3, a negative 3 subtract 3. Right? Make sense? Okay, good. Negative 6. Now we should always answer with negative exponents. So how can I answer this with a negative exponent? Sorry, did I say answer with negative exponents? Sometimes. Okay. I think one thing and then my mouth is something else. Don't you hate when that happens? Okay. So we always want to answer with positive exponents. We don't want negative exponents in our final answer, ever. So who do we have to move? The b, so it becomes negative 4 over b to the power of positive 6. We have to move the b down. This one's interesting. How am I going to take care of this negative exponent? Flip it. Move it to the bottom. So we still have 5q to the 4 on the bottom. And we're also going to move this guy to the bottom to make him positive. So now he's on the bottom. What's left on the numerator? 1. Always 1. Okay, so we moved, because of this negative exponent, we moved this whole guy, it's supposed to be brackets, but it's not working very well, to the bottom to make him positive. Always want to take care of negative exponents first. Now what? Yeah, how can we simplify? We can't do that yet.
Because they're not like terms.
No, the reason why is it's squared. Guess what we have to do before multiplication? Exponents. We have an exponent here. So, don't, well, brackets, yeah. Brackets and exponents, kind of the same idea. Brackets usually means like if you can simplify inside the bracket, right? Here, can we simplify inside this bracket? No. So now we want to move on to this exponent. So when we square this, what does it equal? 25p squared, yeah, we square both of them, times 5q to the 4. So there's one more thing. Now we can do what? The multiplication. 25 times 5, 125 p squared q to the 4. Kind of ugly? I don't know. Maybe not. Turn the page or look at the next page. How are we doing for time? Okay, not yet. We need to move on. We need to look at some of these for sure today. Okay, let's look at a couple of these. Which ones do you want to look at here? B and E? B and E? Okay. Maybe C, but we'll see how this goes. Okay, so brackets. first. If we can simplify inside the brackets first, we will. Can we simplify inside these brackets? Yeah, if we have the same base, what do we do with being multiplied? What do we do with the powers? Add them. So negative 2 plus 0 is still 2 to the negative 2. Okay, we have a power to a power. So what can we do if we have a power to a power? Multiply them. Yeah. Negative 2 times negative 2.
4.
Positive 4 and 2 to the power 4. Does anyone know what that is? 16. Yes.
Square bracket should be
Round.
bracket.
Yeah. Yeah. Square brackets, round brackets, same thing. Should we move on to E? C looks a little like an eyesore. Okay. You really have two options here. We can take care of the negative exponent first, or we can take care of simplifying inside the brackets first.
Simplify inside the bracket.
Sure. So if we have the same base being divided, what are we going to do with our powers? Subtract. So we have 3 minus 5. Be very careful. Negative 2. 3 minus 5 would be negative 2. Now does it look so bad? Oh, why?
No, we just did this.
Power to a power? Be positive 4 or 81. 3 squared times 3 squared, or 9 times 9. Okay. Looking at this guy, yes, Jenny. Did I get the negative 2 here? Because you square it twice. So you go 3 squared, 9, 9 squared, 81. So 3 to the power 4 is the same thing as squaring twice. And the reason why it's the same is because of the power to power rule. Because the power to power, you'd multiply 3 to the power 4. It's the same thing as 3 squared squared. So 3 squared is 9, 9 squared is 81. Okay. If you had to use your calculator, that's okay. Okay, so this guy E, what would you have to take care of first?
The exponent on the outside.
This exponent here, we can't multiply until we get rid of that exponent, right? Good old bad math. Don't forget to apply it to everything inside, including, often students forget the first guy, the coefficient. Okay, so negative 4 cubed. Positive or negative 64? Negative 64. A to that. Okay, so then what do we do with the power to a power here? Multiply. So 2 times 3 is 6. And b to the 9. Okay, so that got rid of that exponent. Now can we multiply? Yeah, I think so. You might want to use your calculator for 64 times 8. No? Okay. Here, Zach, go. Negative what? I believe you, because we could good. Thank you. Thank you. Okay. Now, same base is being multiplied. What's a to the 6 times a to the 1? A to the 7. Remember, this is a 1. We add the powers. Add. And then b to the 17. Good. And we can leave our final answer because all our exponents are positive. Okay, fractional exponents. Let's look at a couple of these. Which ones look kind of tough? D, okay. F, there's multiple F's. This E or this E? This E? This F? Okay, let's look at these guys. Okay, what would we start with this guy? Power to a power. What are we going to do with a power to a power? Multiply it. So a half times a third. When you multiply fractions, go straight across. So 1 times 2, 2 over 6, or x to the 1/3. Always reduce our fractions. Power to a power, we multiply. So if we did half
And then
times 2/3.
And then furthermore, we could even
Take it to a radical if you want.
changing it to
Cubic root of x. Yeah, you're right. Okay, this guy. This 4/3, who does it apply to? Everything inside, including the 8. So 8 is going to become 8 to the power of 4/3, right? This is a 1. Power to power, you multiply. So 8 and 4/3, 8 to the power of 4/3. And 8 to the power of, what's a half times 4/3? 4/6 or, close, 2/3. Okay, so we never want to leave coefficients with exponents. We always have to evaluate our coefficients. It's okay if our variables have exponents because we can't go any further. So we want to evaluate this. So how do I evaluate 8 to the power of 4/3? Cube root of 8 and then to the power of 16. Yeah, cube root of 8 is 2. 2 to the 4 is 16. 8 to the 2/3. So coefficients, you can't leave with exponents. You have to expand them, evaluate them. All right. Okay, this E. Are we good to start multiplying? I know the second E. I really need to work on my formatting, obviously. Go back and change that. 2 times 5. 10. Now, if we have the same bases being multiplied, what are we going to do with our powers? Add them. So we have 3/8 plus a negative 1/8.
Luckily, they're already in the same denominator.
2/8 or, what is 2/8? 1/4. There you go.
Yeah, but 3 plus negative 1 is 2.
3 plus is 2. Is 2, yeah. Okay, do we need to look at this guy? So who do you want to simplify? The numerators first, I guess? Sure, let's simplify the numerator. So same base being multiplied, what do we do with our exponents? Add them. Uh-oh, we have to add 2/3 and 1/2. Well, guess what we're going to need? Make it out of 6. So if you want, we can do this to the side. So we have 2/3 over plus 1/2. So that's going to be, we need over 6. So what will this become? 4/6 timesing by 2, top and bottom, times by 3/6 gives you 7/6. Okay, that was fun. You could also use your calculator to help if you really wanted to. But that takes away the fun. No? Okay. Same base being divided. What we do with our powers? Minus them. Okay, guess what we need? Common denominator. So 12, yes. So multiply top and bottom by 2 would be 14/12. Multiply top and bottom by 3. So that equals 11/12. How pretty is that? No? Okay, let's look at this very last page. How are we doing for time? Not so bad, actually. Not so bad. Okay, these are the ugly guys. I know you shouldn't call them ugly. It's probably not.
Are we gonna have these
Yeah.
in our work, like in our homework?
You're going to have ones in homework like this tomorrow, maybe a couple, and then they will be on your unit test.
Yeah.
I have some other ones.
Let's get started our homework now.
Let's do one of these. Pick one. Okay, so tomorrow we're going to go through G and I. Unless you want to do them now. Get it over with. Okay. Yeah, there's still homework tomorrow. Okay, so where would we want to start with this? Where could we start with this? You could bring in the half to everything. Yeah, you could do that. could we also simplify inside our brackets first? Often it's easier if we can simplify inside the brackets first before we take care of the exponent. You can bring in the exponent if you'd like, but it's easier because 100 divided by 25 is 4. Okay? Now, be very careful. A here, we have to subtract 1 minus 5. Negative 4. And if there's no b on the numerator, it's really b to the 0. So if you have b to the 0, there's two ways you can think of it. If we're subtracting 0 minus negative a half, what happens if you subtract a negative? It becomes a positive. The other way you can think of it, right now, we're putting everything on the numerator. We're simplifying by putting everything on the numerator. So to move the b up, that exponent becomes positive. Okay, there's two ways you can think of it. You could either put b to the 0 on the numerator, so you're subtracting 0 minus negative a half, or realize you know that you're putting b on the numerator, so the exponent changes to a positive. Both ways will work. Okay, now can we bring in the 1/2? Who does that apply to? Everybody, including the 4. A to that, what's negative 4 times a half? Half of negative 4. Negative 2, and a half times a half. A quarter. Okay, what's wrong with this picture? Two things. Negative exponent. And we need to evaluate 4 to the 1/2. What is 4 to the 1/2 the same thing as? Square root of 4, which is 2. And how do we get rid of a to the negative 2? How do we make it positive? Move it to the bottom. Okay, we move it to the denominator to make it a positive exponent, right? Reciprocal of it. All right, so that's fun. No? Okay, so we'll leave the rest of these for tomorrow. Okay? Ooh, this is a great test question. We'll look at that one tomorrow as well. So today, here's your homework. Okay? It's really not that bad. It's going through basic exponent laws, like product rule and really power. It's really not bad at all. I really promise that. And honestly, you guys, a lot of you have like 6s every day, so I'm not too feeling bad at right now. Obviously, the homework's okay. I know.